Welcome to Climate Now, your source to understand the ideas, technologies, and the solutions that we'll need to address the global climate emergency. I'm your host, James Lawler, and happy holidays, everyone. This is part 2 of our series on the voluntary carbon market, also known as VCM. If you missed episode 1 that we released a few days ago, where we covered what the VCM is and how it's changed over the last couple of years, you can find it on your podcast app or on our website, which is climatenow.com. The voluntary carbon market is the market that is formed around the practice of voluntarily sponsoring carbon removal projects in order to offset one's overall carbon footprint via the purchase of carbon credits or carbon offsets. The idea is that companies or individuals can sponsor these third-party carbon removal or avoidance activities and claim the reduction in net CO2 emissions as carbon credits against their own emissions. In the first episode of this series, my guests explained how, in theory, carbon offsetting could be a powerful weapon against climate change, allowing companies and individuals to reach net zero carbon emissions even if they can't directly cut emissions from their own operations. However, many carbon offset methods are under-researched or difficult to verify, and the VCM still lacks a strong regulatory framework. Something else we touched on, which is the focus of today's episode. There are many, many ways to go about offsetting carbon dioxide emissions. Some are better than others. The first carbon offsetting project, spearheaded by the World Resources Institute in 1988, involved paying Guatemalan farmers to preserve forest land rather than clear-cutting it in order to grow crops. The theory being that if the forests were left standing, they could actively continue to consume CO2 and sequester that. Projects like that one would eventually be named REDD+, or REDD+ offsets, which stands for, a bit of a mouthful, Reducing Emissions from Deforestation and Forest Degradation in Developing Countries. Again, REDD+. It's still one of the most popular carbon offsetting methodologies. According to the UN Climate Change Conference, REDD+ projects account for 1.35 billion hectares, or about 3.3 billion acres, in developing countries. Other methods focus on agriculture. Modern agriculture tends to be extremely carbon intensive and accounts for more than 1/10 of global carbon emissions. Agriculture-based carbon offset projects pay farmers to use techniques such as no-till farming, which doesn't involve plowing the soil, thus leaving carbon sequestered in the ground. Another method involves investing in renewable power projects and then claiming a share of the carbon avoided by the generation of that clean power. In our third episode in this series, we'll speak with someone from Clearloop, which is a kind of clean power offset broker that helps businesses invest in solar power projects in other parts of the country and then claim those credits. We'll get into all of the methods that I just described and more. Keep in mind there are pros and cons to all of these methods, and while a particular method might seem straightforward on the surface, there are often secondary considerations to keep in mind when determining whether it really makes sense or is a viable strategy for offsetting emissions. In this episode, we hear from people involved in 3 completely different carbon offset companies trying to provide measurable and verifiable offsets. The first, Vesta, aims to infuse coastal systems with minerals that cause the oceans to absorb atmospheric carbon and sequester it in stone. Next, we'll hear an excerpt from a previous episode with Grant Canary from Mast Reforestation, a company that generates carbon offsets by maintaining and protecting forests in wildfire-prone areas. Finally, I'll speak with Louis Azor from Climeworks, a company that engages in direct air capture, meaning filtering carbon dioxide straight from the atmosphere and then sequestering it underground. My first pair of guests are involved in ocean-based carbon dioxide removal, or ocean CDR. Climate Now actually produced a series on ocean CDR and the so-called blue economy in August of 2022. If you're a new listener and are interested in ocean CDR, definitely check it out. It's on climatenow.com. There are several different ways to harness the oceans for carbon removal. One of the simplest ideas involves growing tremendous amounts of kelp to consume CO2 in a similar manner to forestry-based carbon removal projects. Some of these projects ensure that when the kelp dies, it then sinks to the depths of the ocean, sequestering the carbon on the bottom of the sea. A 2016 study published in Nature Geoscience estimated that kelp naturally consumes around 200 million tons of CO2 every year, which is roughly the equivalent of the annual emissions of the state of Florida. That said, if that kelp doesn't sink to the bottom of the ocean, the emissions that result from it breaking down, methane and CO2, are released back into the atmosphere. My guests, Kelly Earhart and Tom Green, are commercializing another natural process to capture and sequester carbon in the oceans. Kelly and Tom are president and CEO, respectively, of a company called Vesta, which infuses coastal systems with alkaline minerals, causing the seawater to absorb CO2. This approach is called ocean alkalinity enhancement, and Vesta achieves it by spreading a kind of alkaline sand known as olivine over coastlines. The process that Vesta employs occurs naturally, and it is one of the processes that has allowed the oceans to act as a natural carbon sink for billions of years. But Vesta speeds that process along. They are both here to explain more. Kelly and Tom, welcome. Welcome to Climate Now.
Thank you. Great to be here.
Yeah, thanks for having us.
So before we dive into what Vesta is doing, we've covered a variety of emissions removal. Could you sort of paint a picture of where you play in that space?
Yeah, for sure. I would say approach is sort of categorized in the following way. You've got terrestrial approaches, such as planting trees. You've got engineered approaches, such as direct air capture. And you've got ocean-based approaches. And we fit in with the ocean-based approaches. There's a couple of interesting things about the oceans. One is that outside of rocks, they're actually the largest carbon sink on the planet. So they've already absorbed about 30% of the excess carbon dioxide that we've collectively put into the atmosphere. The other thing here is that because of that, they've become 30% more acidic. So with ocean acidification, that's actually contributing to putting marine ecosystems on the brink of collapse, and that's contributing to things like coral bleaching, which I'm sure a lot of people have heard of. So the goal with what we do is actually to sort of heal the ocean climate nexus, because what we can do is we can help the oceans to safely remove carbon dioxide from the atmosphere while actually reducing ocean acidification at the same time. So that's what I mean by ocean climate nexus. It's all connected. It's connected, at least in one way, through carbon dioxide.
Yeah.
So the sort of terrestrial-based approaches, trees, soil-based approaches, things like that, those are all working within the short-term carbon cycle. But the long-term carbon cycle is what actually regulates carbon levels on Earth. And so this is a cycle that works through a series of natural chemical reactions that occur between rainwater, rocks, and the atmosphere, where slowly over time, rainwater dissolves alkaline rocks. And as that happens, carbon dioxide moves out of the atmosphere and into water as bicarbonate, and then eventually into the ocean, eventually can turn into calcium carbonate, where it eventually can then become rocks. And then over very long timescales, those rocks can then become magma, and then that can erupt through volcanoes. And so that's kind of the long-term carbon cycle. And it's been happening for billions of years.
The connection between the ocean and atmospheric carbon is as old as planet Earth. The oceans have always been a regulator for carbon through a phenomenon called the long-term inorganic carbon cycle. Alkaline rock erodes from mountains and cliffs and flows into the oceans, which react with atmospheric CO2. This reaction produces something called dissolved bicarbonate, which is an important ingredient for coral and shells, which eventually become limestone. Scientists estimate that this cycle removes around 1 gigaton of carbon dioxide from the atmosphere every year. The problem is that the cycle can't keep up with the vast quantities of additional CO2 that humans are pumping into the atmosphere every year. One solution, according to Vesta, is to speed it up. Vesta's method is called coastal enhanced weathering, which involves infusing coastal systems with alkaline minerals, specifically the mineral olivine, which is one of the most abundant minerals on Earth.
And when olivine dissolves in seawater, it has this amazing property. It can remove carbon dioxide from the atmosphere by converting it into alkalinity in the ocean.
Vesta adds olivine-rich sand and gravel to shorelines and other coastal systems, some of which dissolves into the seawater, which then reacts with CO2 molecules that have been dissolved into that water. By removing those CO2 molecules, more CO2 can then be absorbed into that ocean water, thereby drawing down atmospheric carbon dioxide. Vesta claims that each ton of dissolved olivine sand can capture just under a ton of atmospheric carbon. There are, of course, several links in that chemical process chain. The challenge that Vesta has is to figure out in what conditions and how well that process works, and to be able to verify it in a rigorous way for buyers of those carbon credits.
But carbon dioxide removal is not the only solution that we're providing with this approach. So a linked issue to climate change is sea level rise. And as climate change worsens and waters warm, ice melts, storms become more intense, sea level rise and erosion is increasing. And so the sand that is being used to protect coastlines is becoming something that is in short supply. And so what we can also do is use our carbon removing sand in coastal protection projects so that we can not only remove carbon dioxide from the atmosphere to help with climate mitigation, but also add resilience and adaptation benefit to coastal communities, which is what we did at our first pilot project in New York State, in Long Island, which we launched last year. In July 2022, we deployed the world's first pilot project of this solution, and we did so in the town of Southampton. So we added 500 cubic yards of olivine sand to the town's larger coastal protection project. And the results so far have been incredibly encouraging. So we have a little over one field season of data in. We're into our second field season now. And the initial results from this deployment are available on our website. And what they show is that the process is ecologically safe and that carbon dioxide is being removed from the atmosphere.
Now, how do you know? Because the ocean is obviously not a closed system where you can clearly measure inputs and outputs. And like, how do you possibly know whether this has worked or not?
Yeah, as I'm sure you can imagine, this is a common question, and this is a lot of where we focus our R&D efforts. So we've got a team which includes 13 PhD scientists and engineers as well. And what we have developed is a system for measuring the carbon removal that happens, and we measure it right where it happens. So we take direct measurements at field deployment sites, and then based on those measurements, we've developed a set of models that enable us to calculate the amount of CO2 that's actually being removed from the atmosphere.
Can you paint a picture of that? So when you say you measure it at the site, what exactly is being measured?
So we've developed hardware that enables us to measure the changes, the subtle changes in seawater chemistry that occur when olivine sand dissolves in the water. So, for example, one of those changes is a slight increase in pH, which, as we've talked about earlier, counteracts damaging ocean acidification. So we've developed hardware that enables us to directly measure that. And so we measure that in a few different sample points on a deployment, and we use a modeling approach to combine the data from those and use it to calculate carbon removal. So another key thing we measure will be alkalinity. So alkalinity, that's the bicarbonate that Kelly was talking about earlier. That's the mechanism for actually removing carbon dioxide from the atmosphere. And so we're able to measure that directly.
Great. I'd love to ask you about the business model now. So it sounds quite interesting. You've identified sort of this existing business of coastal protection, but you're also drawing down CO2, which we know people pay for. So could you sort of elaborate on that?
Yeah, for sure. So we work very closely with the shoreline protection industry. So this is deploying about 60 million tons of sand per year in the US, and that's growing. Coastal communities are desperately in need of sand, and there's actually a scarcity of sand at the moment. So we're running out of sand for shoreline protection, which is one reason why these projects are actually becoming more expensive over time. So what we do is we provide the sand more cheaply to coastal communities which are in need of sand for shoreline protection. And then we can do that because we then also earn revenue from selling carbon removal to companies that have commitments to mitigate their climate impact. So our business model involves two revenue streams. The first is sand for shoreline protection, and the second is carbon removal revenue.
Well, Tom Green and Kelly Earhart, thanks so much for coming on the show and explaining all of this to us.
Thank you.
Yeah, thanks for having us.
As we said at the top of the show, forestry-based carbon offset projects are the oldest and one of the most popular sources of carbon credits. But in recent years, these sorts of carbon credits have also become some of the most scrutinized. This is because when it comes to forests, there are a lot of question marks. Can we really tell exactly how much carbon such complex ecosystems are consuming? If you pay to preserve a forest in a distant country, how can you be certain the forestry firm will honor its agreement in the long term? Or that the local government won't seize the land? Or that a fire won't burn the forest down? Or that the forest wouldn't have been left standing anyway, regardless of your investment? Or that by preserving that forest, you're not encouraging a forestry firm somewhere else to cut down another forest that maybe isn't protected? These are questions of additionality and leakage. In other words, whether or not an investment in a carbon offset actually produces an additional effect on the atmosphere that wouldn't have occurred otherwise, and that doesn't in turn cause some deleterious effects somewhere else. Research shows that the VCM is full of junk credits or phantom credits that either don't have additionality, that are prone to leakage, or where the underlying project does not guarantee permanence, meaning that the CO2 would be sequestered away permanently in forestry-based offset projects. Earlier this year, a multi-party investigation led by The Guardian found that more than 90% of the rainforest-based forest offsets approved by Verra, which is the VCM's leading carbon credit certification agency, were phantom credits with no additionality. Likewise, another study published in the journal Science looked at forest-based offset projects in developing countries that accounted for a total of 89 million carbon credits, also approved by Verra. The study found that only 6% of those credits had any additional carbon benefit. Again, for our listeners, you can find links to these studies on the Climate Now website in the transcript for this episode. So is it possible to do forestry-based carbon offsetting properly? How can you guarantee to the buyer of your carbon credits that the forests that they're investing in will actually make a difference? In a previous episode of this podcast, I had a chance to speak with someone who is trying to tackle that challenge. Grant Canary is the founder and CEO of Mast Reforestation. It's a company that replants, cultivates, and maintains wildfire-ravaged forests. It also engages in forestry projects that make forests more wildfire resistant. Mast Reforestation, it's the name of the company, funds its operations through the voluntary carbon market. The company measures the carbon that is sequestered by the forests it protects and restores, and sells those carbon offsets. At the start of our conversation, Grant pointed out that climate change not only causes more destructive wildfires, but also that those fires release massive amounts of CO2 into the atmosphere when they occur.
The 2020 California wildfire season emitted something like 127 million metric tons of carbon into the atmosphere. And the 18 years of policy wins of EVs and different energy sources and other things to reduce emissions was something like 65 million metric tons. So one fire season wipes out 18 years of hard-fought wins in the space. That's just devastating.
Grant described how truly devastating fires, the kind that are becoming more frequent due to climate change, can destroy even buried seeds. Nothing is left. The forest is gone for good.
Most people assume, well, that's really awful, but the forest will grow back. And I guess what we're trying to say is without human intervention, a lot of those forests are not coming back. It used to be 90% of the time forests would come back. Now we're seeing that drop, broad brushstrokes here, 40 to 60% of the time. So that's a lot of acreage that all of a sudden is not restoring that carbon that was emitted in the fires. And so that's something where we absolutely need the opportunity to get in there and intervene.
Mast Reforestation handles every step of the restoration projects, from gathering trees, nurturing seedlings, planting the new trees, and long-term maintenance. The company has 3 subsidiaries, one that uses drones to conduct aerial reseeding services, another that supplies the seeds themselves, and a nursery that supplies saplings for California reforestation projects. A lot of the company's revenue comes from the voluntary carbon market.
Despite $1 a tree campaigns and such, there's a lot more than just the tree that goes into the labor, the site preparation, etc. So a couple thousand acres can be $4 or $5 million to reforest. And where's that money come from? Carbon removal credits. Without carbon removal credits, there's no money for our work with reforestation. There's no money for ocean-based removals. There's no money for direct air carbon capture. That is the system that pays for this work.
But I had questions for Grant about the durability of these credits. So let's say that I do this and I fund reforestation of a forest, which is reforested. Mast comes in, uses that money to plant a bunch of trees on some acres that were severely burned. And you reseed, you replant, but there isn't rain then the next season or the next 2 seasons, or new insects come in, or the fire comes back in that area and those trees are burned or they're dead. What happens with that carbon credit that I've purchased? Because, clearly the carbon was not stored, right? So when you sell the credit, what kind of permanence provision is in that sale? Like, how long are you saying that the carbon that is going to be stored will be permanently stored when you sell a credit?
Yeah, we're rated for 200 years. I think Pachama and others make a really credible argument that the life of a tree might be 50, 100, 200, 500 years, but the life of a forest as a larger organism, when we have a low density forest, which results in low severity fires most often, then we can have a forest that can be much longer. So as a part of the project, what occurs is that there's an easement that's placed on the land. This is within the United States. So that is a right that's held by a land trust, and it's a nonprofit third party to a minimum quantity of trees per acre. And so as part of the project setup costs, they've got a right for 100 to 200 years, depending upon the state, to that minimum quantity of trees per acre. That sits at the county. So some landowner wants to sell the property, move on, whatnot. That sits with the property. Now, 100 years is a long time, and that right is only good if somebody's monitoring. So as part of the project setup costs, there's an endowment similar to any university, Harvard, Yale, Stanford. It's invested in the market, provides a percentage return. And that pays for a site visit every 5 years for the next 100 plus, and a site report every year. That right now is boots on the ground, and that's what that endowment pays for. There's tax benefits for those landowners as well, depending upon state, county, federal law, where they're at. And so that's something that's really beneficial in that regard.
That sounds good, but what we're selling in the contract is carbon removal, right? We're not selling that you're going to get for these dollars a minimum trees per acre on a certain number of acres. Like, you're selling carbon removal. So how do you guarantee carbon removal in a stand of trees? Let's consider that we're not actually talking about individual trees, we're talking about forests. But what happens if it burns before they're 50 years old and the carbon that you think you've stored is gone? What happens then?
Yeah. Well, let's go back to the credit issuance. So we planted the trees.
Yeah.
Now we wait, and we wait a year. And the reason we wait a year is because there's a lot of campaigns out there that have been like, we planted 100,000 trees or whatever. You plant them with the wrong root angle. You plant them in the wrong place. They're going to be all dead. So there's a minimum of 1 year wait that Climate Action Reserve requires. So then Climate Action Reserve's like, all right, great, we're going to issue some credits. But before they do, they're like, hey, we realize there's this risk of a reversal, which is a nice industry term for fire, insects, ice, other things that can kill trees. So we're going to take a portion of those credits and we're going to put them into a buffer pool. Every project contributes into this pool. And if there is a reversal, then our buyers know that the credits are either coming from the pool or they're coming from the project, one of the two. And then the question was like, well, but fires are going to go up. Yes. And what do insurance companies do in this case? They increase premiums. So increase the percentage that goes into the pool. This is how we do risk management and abatement is we have projects and they balance each other out in the total tonnages. And then the landowner has that capital from the carbon removal credits that if they are impacted, they can go out there and reforest.
Grant acknowledged that the VCM has a long way to go in terms of transparency, verification, and accountability. But he still believes it is an essential component of the global effort against climate change, and he's optimistic that it will improve with time.
Let's just acknowledge, yes, some carbon credits just completely are not moving the needle on mitigating the worst effects of climate change. They suck. But there's 177 types coming from 100 plus countries. So I think the nuanced view that I want to bring to people is while there's definitely criticism warranted of some of those, we're in a place where there are a number of different types of carbon credits, and it's important to start to analyze and figure out what are the ones that are moving the needle. We're coming up with the definitions, we're coming up with the accounting for this, and to the extent that where Bloomberg NEF says, hey, price of carbon in two of our three scenarios goes to $200 a ton by 2030 if we're focused on removals. And that's what we do. We do removals post-fires with trees. But there's ocean-based, there's biochar, there's direct air carbon capture. There's a number of other technologies coming online that remove carbon out of the atmosphere, which we absolutely need to do because thought experiment, humans are gone tomorrow. All of the ecosystems would still experience all of the changes in climate because we've already locked in, because of what's already out in the atmosphere, so much warming. And so we have to do removals, and this pays for it.
Both Vesta and Mast Reforestation harness natural processes that hopefully result in a net reduction of atmospheric carbon dioxide. Direct air capture, or DAC, employs technologies that remove carbon directly from ambient air and then sequester it. Many DAC sites look like giant stacks of boxes, each with a massive fan that pulls in air and exposes that air to special solvents or sorbents that react with the CO2 and capture it. Direct air capture has one clear advantage over the other offset methods that we've looked at so far. It is more possible to actually quantify the amount of carbon dioxide that has been removed. The downside is that DAC is very expensive and very energy intensive. Those aforementioned stacks of fans require a considerable amount of power to operate, which undercuts the total amount of carbon that is offset unless that power is generated by clean sources like solar or wind. But then, of course, the question is, would there have been a better use for that solar or wind rather than to use it to power DAC? For example, for it to be used by an entity that is currently emitting CO2 because of their power that is generated by clean sources like solar and wind. But then the question is, what is the best use from a climate standpoint for those green electrons? Is it to power a DAC facility, or would it be to power, let's say, an industrial facility or a warehouse that is using more carbon-intensive grid power to run its operations? In most cases, it's probably better to reduce the emissions of existing emitters rather than power a DAC hub to take carbon dioxide out of the atmosphere. Some DAC companies are experimenting with more efficient technologies. For example, Ireland-based carbon capture firm Carbon Collect is developing a passive air capture system called Mechanical Tree that harnesses natural wind currents to power its carbon removal. But as of yet, the total amount of carbon captured in this way is very low. Direct air capture is still very new. According to the International Energy Agency, only 27 direct air capture facilities have been commissioned worldwide as of 2023, removing less than 0.01 million tons of CO2 per year. Louis Uzor is Climate Policy Manager at Climeworks, a Swiss direct air capture company that launched the first commercial-scale DAC facility in 2021 in Iceland, which can capture 4,000 tons of carbon dioxide per year. In 2022, Climeworks broke ground on a second Iceland site that it claims can capture 36,000 tons of CO2 annually. The company claims to reach the megaton scale by the 2030s and has the ultimate goal of capturing a full gigaton of carbon dioxide annually by 2050. That is an extremely ambitious goal, but Louis Uzor believes that DAC could indeed be the future of high-quality carbon credits. Louis, it's great to have you on Climate Now. Thanks for joining us.
Yeah, many thanks, James, for the kind invitation. I was looking forward to this talk.
I'd love to start now with what exactly does Climeworks do, and what is the product that you are offering to the market specifically?
Yeah. So what Climeworks does is best described as carbon dioxide removal. So we, as a company, we build and operate and also sell the product of machines that filter CO2 out of the air. And so our machines, they look like shipping container-sized boxes stacked on top of each other. It works a bit like a sponge. So you draw something in, so we pull air through the systems, and then we squeeze the sponge in that sense, or we heat it up to 100 degrees Celsius. And by that temperature, the CO2 that was stuck at the filter within the box gets then released, and we can do something with it. And so what Climeworks primarily does with it is to store it, or actually not ourselves. We work together with storage companies like Carbfix, our Icelandic storage company, and partner to an important project. And thereby we generate negative emissions. So we actually pull CO2 from the air and store it for almost permanent timeframes. So once it's underground, it actually just stays there in the first place. And we are happy about that, because by staying below ground, it doesn't hurt the climate.
Climeworks sequestration technology converts the carbon dioxide it captures into a mineral form, actual physical lumps of carbon-rich rock. But according to a report by Carbon Brief, Climeworks' current facility in Iceland, dubbed Orca, requires around 10,000 megawatt-hours of heat energy and 2,000 megawatt-hours of power to capture those 4,000 tons of carbon dioxide per year. Louis says the power and energy demands are precisely why Climeworks is operating in Iceland, a place with abundant hydropower and clean geothermal energy sources.
What we do is we really look for these locations where there is abundant renewable energy, and Iceland is one of those cases. And it's important for two things, or two aspects. And the first one really being that Iceland has a almost 100% carbon-free grid. It has more potential, so we are not drawing away from other sources if we apply our technology within that context. And then secondly, what the major component of energy that the machines need is actually energy in the form of heat, so thermal energy. And with its geothermal energy sources, we can actually just directly plug into those. Actually, it's a waste stream from the geothermal power plant in the first place that we can then just tap in once more and get the heat to run the process.
So flipping to the other side of the coin, which is really what we were especially excited to get into with you today, the marketplace. So Climeworks is, operating this technology with its partners. It's sequestering a certain number of tons of CO2 per year, and then it's monetizing those activities through what are known as the voluntary carbon offset markets. So tell us, Louis, how does that work exactly? Do you just stand on like a street corner and wave a flag that says carbon storage here, come and get it? Like, how does this work?
It's not as easy as that, although standing at the street corner also sounds a bit tough to some extent. No, but in our case, what we do is we rely on, let's say, what we have seen from the conventional carbon, like voluntary carbon markets, where you have entities like greenhouse gas programs that certify or validate or verify activities. So at the end of the day, the output of our activities is a negative ton of CO2. And it's not something that you get mailed by your postman or that you can get physically, because it's best stored deeply below ground and not touched by anyone. But then you still want to have the proof of the activity of the process, that it happened according to a certain form of rules, or to according to a certain level of stringency or standards in general really define the product. And when we in 2018 first looked at the landscape of, okay, how could we certify what we do? How could we work with those standards and embed the product? It was quite hard, so it wasn't much available for standardized direct air capture processes. And from that, it really was a journey, and we are still amidst that journey to define and cooperate with many others in this field to define what does it take to capture CO2 directly from the air, and how do you go about measuring, how do you go about making sure that the measurement devices in and of themselves are calibrated according to the right set and so forth.
Climeworks' goals are extremely ambitious. The company aims to capture carbon dioxide by the tens of thousands of tons in the next decade and achieve a full gigaton of carbon drawdown by 2050. Whether or not it can deliver those numbers of carbon credits remains to be seen, but assuming it can, there is one obvious difference between a carbon credit from Climeworks and one from another type of offset, like a forest preservation project. It's completely verifiable, but it's also more expensive. I wanted to know how much a Climeworks credit costs.
So I think on CDR as a broad category, we generally see a lot higher prices than what was conventional prices for avoided emission credits or reduced emission credits. And that just goes with the nature of CDR in and of itself, because it's always harder to get the CO2 out of the air again than just avoiding it in the first place. So that kind of differentiation is included in the price to quite a high degree. And then I think the other aspect that's important when we look at those prices is the aspect of the permanency or the durability of whatever you have bought. So for how long does a project developer guarantee that the CO2 actually stays stored? And according to that axis, you really see that the higher permanency or more durable projects really get higher valuation on a per ton credit basis. So in our case, Climeworks, we have a public web shop selling above $1,000 per ton of CO2 sequestered and stored. And so that's really almost like at least a factor 500 the price that you see for a conventional avoided emissions, let's say RED Plus project or something like that. And so that really caters to two things. First, it's a removal credit that is extremely durable. So the IPCC described the geological storage as the approach to storing CO2 that's the highest in that durability aspect. And the second thing is then still that you have a general new market. So many of the CDR projects are first of a kind projects, are kind of early stage and not yet at scale. And so that kind of new industry premium is also included in the price. So at Climeworks, for example, we foresee massive price reductions to actually make a difference by 2050.
So let's talk about the accreditation piece here that basically verify a given practice actually removes CO2 and sort of verifies the project plan and the product that is being sold. And I'm wondering if you could talk about the relationship between these registries or accreditation agencies and the companies that are operating
Hmm.
and how that works.
Yeah, so maybe once more the personal story or how it happened at Climeworks. So in 2018, we started looking into what standards are available to Climeworks, and actually we didn't find many that are applicable to us. So there was one out requiring project developers to work with enhanced oil recovery, EOR, and was predominantly located in the US. So that wasn't the standard that we wanted to work with or couldn't work with. And then we had to look at other standards, registry developers, and actually all of them were at first quite reluctant to work with direct air capture and geological storage. And so that was a long process, and we had to find the right partners. And so we first partnered up with an agency called DNV. DNV, they are a what we call VVB, verification and validation body. So really an agency that can come to your project and understand industrial processes, predominantly emitting processes. So DNV is a market leading auditor for emission trading scheme covered entities here in Europe. And so they know quite well how emissions from an industrial process land in the atmosphere. And we partnered with them to develop a protocol or a rule book for basically the reverse. How do you get CO2 from the atmosphere and how do you prove that it's safely stored?
Louis, give us a sense of what that means. So, in terms of the ability to operate in a commercial space, what are some of those requirements when it comes to providing a product to the marketplace that people will actually buy and feel good about?
So actually, there weren't many requirements available for Climeworks. It was really our own kind of ambition to do something that's high quality, that is trustworthy and pure, that led us to look at many things in a different way. For example, construction emissions are a thing that we wanted to see included in all cases. Other things like we have probably applied more stringency to those protocols than what was usual, but we believe that this is extremely necessary for carbon dioxide removal in particular, because it's about guaranteeing that you have actively pulled something out of the atmosphere. And then it matters how much you have produced in the process from a cradle to grave kind of lens.
There does seem to be a conflict of interest in the relationship between the registries or the accreditation agencies and the project owners and operators, because again, project owners and operators are paying these third parties to come in and provide their stamp of approval. Those companies' funding comes from the companies, and so they're not. You couldn't call them fully independent, and they both have sort of the same interest of providing a stamp of approval at the end of the day, and their customer has to have trust that this is actually happening.
Yeah, what you have described really pertains to the voluntary carbon market. And I think it's important to differentiate between a compliance carbon market and the voluntary carbon market. So the key difference is that in a compliance market, somebody like a regulator, a municipal regulator, or even state level regulator comes in and says you have to comply with X, Y, Z, and they develop the rules according to which you should go in your process and according to which you should really report and inform the authorities again about what you have done. And so that whole control function and whole monitoring of emissions has happened in a situation where companies haven't paid a specific entity to come by, but they just did so because they had to comply with the law. And so I think that really key difference is there, because then it's a really a market with independent governance setups. And opposing to that, we have the voluntary carbon market. So if there is activities or customers that want to do something, even though they aren't obliged to do so by law, they have to kind of define their own rules of what counts and what not. And therefore, the voluntary carbon markets have developed various actors along the value chain, sometimes even sitting on top of each other and making for a ecosystem that should kind of in the absence of the governance from a regulator, make sure that quality is there. And so we have, validation, verification bodies, we have certifiers, we have rating agencies, we have buyers codes, and we have suppliers codes on a meta level that now label what is a kind of core carbon principle and so forth. So there is really a range of activities around it.
So you really see the whole voluntary carbon market as being a transitory phenomenon on the road to fully mandatory, legally binding regulation.
I would say so, yeah, but here really thinking in longer time frames, so 20, 30, 40 years, something like that. And up to that point in time, the voluntary market serves various purposes, from just pioneering new activities, developing new things for new activities, and so forth. That's extremely important, but also for buyers to get an understanding of what that actually means, be in contact with the ones producing that, because you anticipate or because you voluntarily do something.
Well, Louis, it's been really great to talk to you today. Thank you for your time. Thank you for joining us on Climate Now.
Likewise, James, it was a pleasure, and many thanks for having me here.
That's it for part 2 of our deep dive into the voluntary carbon market. Thanks again to Louis Azor, as well as Tom Green and Kelly Earhart, and to Grant Canary for joining the series. In our next and final episode in this series, we will look at the market as a whole and whether it might be possible, and if so how, to bring all of these various methodologies for carbon dioxide removal into a single market and achieve consistent standards of pricing, verification, and regulation. We'll talk to buyers of these offsets as well as the registries verifying the offsets. Until then, you can learn more about carbon credits and carbon offsetting in our previous episodes on climatenow.com. And please let us know what you think. We love to hear from our listeners. Reach out to us via email at contact@climatenow.com. We promise we'll respond, and we hope you'll join us for our next conversation. Climate Now is made possible in part by our science partners like the Livermore Lab Foundation. The Livermore Lab Foundation supports climate research and carbon cleanup initiatives at the Lawrence Livermore National Lab, which is a Department of Energy applied science and research facility. More information on the Foundation's climate work can be found at livermorelabfoundation.org.